Good evening. As you settle into a comfortable position, allow your body to relax and your mind to drift gently. Tonight, we embark on a serene voyage through the vast expanse of our solar system. Imagine yourself aboard a quiet spacecraft gliding smoothly through the cosmos. Our journey begins here on Earth, our home, as we prepare to explore the wonders that lie beyond. Take a deep breath and feel the tranquility of space envelop you. We lift off from Earth, leaving behind the familiar blue marble suspended in the darkness. As we ascend, the curvature of our planet comes into view, the thin veil of the atmosphere glowing softly against the blackness of space. Below, the continents and oceans stretch out, a tapestry of blues, greens and browns. Cloud formations swirl gracefully, painting ever-changing patterns across the sky. Our spacecraft moves silently, and soon Earth becomes a distant sphere, a silent guardian watching over our departure. Passing through the exosphere, the outermost layer of Earth's atmosphere, we enter the realm of space. Here, particles are sparse, and the temperature can vary dramatically between sunlight and shade. We leave behind the last traces of Earth's protective embrace. Our first destination lies inward, towards the heart of our solar system. We set a course for the Moon, Earth's constant companion. Orbiting at an average distance of about 384,400 kilometers, the Moon has watched over Earth for billions of years. As we approach, its surface reveals a rugged landscape of craters, mountains, and vast plains called maria. These maria are basaltic plains formed by ancient volcanic eruptions. The largest, Mare Imbrium, stretches over 1,100 kilometers across. Imagine the stillness of the lunar surface, unchanged for millennia, bathed in stark sunlight and deep shadows. We glide over the Apollo landing sites, silent monuments to human exploration. Our journey continues as we turn towards the inner planets. We pass by the Lagrange points, areas of gravitational balance between Earth and the Moon, where objects can remain in stable positions relative to both bodies. These points are of interest for future space exploration and potential habitats. Leaving Earth's gravitational influence, we head towards the Sun. Our path takes us near the orbit of Mercury, the closest planet to the Sun. Mercury orbits at an average distance of about 58 million kilometers from the Sun. As we approach, we notice its barren, cratered surface, reminiscent of our Moon. Despite being the closest planet to the Sun, Mercury is not the hottest. This is due to its lack of a significant atmosphere to trap heat. Temperatures on Mercury can range from a scorching 430 degrees Celsius during the day to a freezing minus 180 degrees Celsius at night. Mercury's orbit is the most eccentric of all the planets, meaning it varies significantly in distance from the Sun during its orbit. This results in unique phenomena such as double sunrises and sunsets in certain regions. We observe Caloris Basin, one of the largest impact craters in the solar system, spanning about 1,550 kilometers in diameter. The impact that created it was so powerful that it caused seismic waves that disrupted the terrain on the opposite side of the planet. Our spacecraft gently loops around Mercury, and we feel the subtle tug of the Sun's immense gravity. Next, we chart a course to Venus, Earth's sister planet. Venus orbits at about 108 million kilometers from the Sun. As we approach, the planet shines brilliantly, often visible from Earth as the morning or evening star. Venus is enveloped in a thick atmosphere composed mainly of carbon dioxide, with clouds of sulfuric acid droplets. This dense atmosphere creates a runaway greenhouse effect, making Venus the hottest planet in our solar system, with surface temperatures around 465 degrees Celsius. The atmospheric pressure on Venus is about 92 times that of Earth's at sea level, equivalent to the pressure found 900 meters underwater on Earth. The surface of Venus is hidden beneath its clouds, but radar mapping reveals a landscape of vast plains, highland regions, and thousands of volcanoes. Some of these volcanoes may still be active today. We contemplate the mystery of Venus's rotation. It spins in the opposite direction to most planets, a phenomenon known as retrograde rotation. A day on Venus is longer than its year, taking about 243 Earth days to complete one rotation and 225 Earth days to orbit the Sun. As we leave Venus, we reflect on its beauty and harshness, a planet of contrasts. Our journey brings us back towards Earth, and we take a moment to appreciate our unique planet from a new perspective. Earth's atmosphere not only sustains life, but also protects us from harmful solar radiation and small meteoroids, which burn up upon entry. We think of Earth's magnetic field, generated by the movement of molten iron in its outer core. This magnetic field creates a protective bubble called the magnetosphere, shielding us from charged particles emitted by the Sun. These particles interact with Earth's atmosphere near the poles, creating the mesmerizing auroras, the northern and southern lights. Continuing our voyage, we set our sights on Mars, the red planet. Mars orbits at about 228 million kilometers from the Sun. As we approach, its reddish hue becomes more pronounced, a result of iron oxide or rust coating its surface. Mars is home to the tallest volcano and the deepest, longest canyon in the solar system. Olympus Mons, the massive shield volcano, rises approximately 22 kilometers above the surrounding plains. Valles Marineris, the colossal canyon system, stretches over 4,000 kilometers long and reaches depths of up to 7 kilometers. Mars has polar ice caps made of water ice and dry ice, frozen carbon dioxide that change with the seasons. These caps expand and contract as Mars tilts on its axis, similar to Earth's seasonal changes. Evidence suggests that Mars once had liquid water flowing on its surface. Dried riverbeds, mineral deposits, and sedimentary layers indicate a wetter past. Rovers like Curiosity and Perseverance continue to explore the Martian surface, searching for signs of past microbial life. We imagine the thin Martian atmosphere, composed mostly of carbon dioxide, and the dust storms that can envelop the entire planet. Mars has two small moons, Phobos and Deimos, thought to be captured asteroids. Phobos is gradually spiraling inward and may eventually break apart or crash into Mars. Leaving Mars, we venture into the asteroid belt, a region between Mars and Jupiter filled with remnants from the solar system's formation. The asteroid belt contains millions of objects, ranging from tiny dust particles to dwarf planets like Ceres. Ceres, the largest object in the asteroid belt, is about 950 kilometers in diameter. It is composed of rock and ice and may have a subsurface ocean. The asteroid belt is not densely packed. Objects are spread out over vast distances. Our spacecraft navigates through this region with ease, passing by various asteroids of different shapes and sizes. Some asteroids have moons of their own, and others are binary systems where two similarly sized bodies orbit each other. We reflect on the importance of asteroids. They are considered time capsules from the early solar system, containing pristine materials that can offer insights into its formation. Some asteroids contain valuable minerals and metals, sparking interest in potential future mining operations. As we exit the asteroid belt, we approach Jupiter, the giant of our solar system. Jupiter orbits at about 778 million kilometers from the Sun. Its immense size is awe-inspiring. Over 1,300 Earths could fit inside it. Jupiter is a gas giant composed mainly of hydrogen and helium. Its atmosphere is a tapestry of colourful bands and spots created by strong winds and storms. The most famous of these is the Great Red Spot, a massive storm larger than Earth that has been observed for over 350 years. We observe the intricate cloud patterns swirling in shades of white, brown, orange and red. Jupiter's rapid rotation, completing a day in just under 10 hours, causes it to bulge at the equator and flatten at the poles. Jupiter has a faint ring system and a powerful magnetic field, the largest of any planet. This magnetosphere traps charged particles, creating intense radiation belts. Our spacecraft is shielded as we pass through this region. Jupiter is orbited by at least 79 moons. The four largest, known as the Galilean moons, are Io, Europa, Ganymede and Callisto. Io is the most volcanically active body in the solar system, with hundreds of volcanoes erupting sulfur and sulfur dioxide. Europa is of great interest because it is believed to have a subsurface ocean beneath its icy crust. This ocean may contain twice as much water as all of Earth's oceans combined. Ganymede is the largest moon in the solar system, even larger than the planet Mercury. It has its own magnetic field and shows evidence of a subsurface ocean. Callisto's heavily cratered surface is one of the oldest landscapes in the solar system. We marvel at the diversity of these moons, each a world unto itself. Continuing our journey, we arrive at Saturn, the jewel of the solar system. Saturn orbits at about 1.4 billion kilometers from the Sun. Its magnificent ring system is unparalleled, composed of ice and rock particles that range from tiny grains to objects the size of mountains. The rings are divided into several sections, named alphabetically in the order they were discovered. They are incredibly thin, often just 10 meters thick, despite stretching over 280,000 kilometers in diameter. Saturn is a gas giant like Jupiter, primarily made of hydrogen and helium. It is the least dense planet in the solar system. If there were a bathtub large enough, Saturn would float. Saturn's atmosphere features bands and storms, though they are more subdued in color compared to Jupiter. Occasionally, massive storms appear, encircling the entire planet. Saturn has at least 82 moons, with Titan being the largest. Titan is larger than Mercury and has a thick atmosphere rich in nitrogen, with clouds of methane and ethane. Its surface features lakes and rivers of liquid hydrocarbons, the only other place in the solar system known to have stable liquid on its surface. Enceladus, another of Saturn's moons, has geysers that eject plumes of water vapor and ice particles from its south pole. These plumes feed into Saturn's E-ring and suggest the presence of a subsurface ocean, making Enceladus another candidate in the search for extraterrestrial life. We take a moment to appreciate the beauty of Saturn's rings, casting shadows on the planet below. The interplay of light and shadow creates a serene and timeless scene. Our spacecraft continues outward to Uranus, the first planet discovered with a telescope. Uranus orbits at about 2.9 billion kilometers from the Sun. It is classified as an ice giant, with an atmosphere rich in water, ammonia and methane ices. Methane in the upper atmosphere absorbs red light, giving Uranus its characteristic blue-green color. One of the most unusual features of Uranus is its axial tilt of about 98 degrees. This means it essentially rotates on its side, causing extreme seasonal variations. Each pole gets around 42 years of continuous sunlight, followed by 42 years of darkness. Uranus has a faint ring system and at least 27 known moons, named after characters from the works of Shakespeare and Alexander Pope. Miranda, one of its moons, has a bizarre, patchwork surface with giant canyons, terraces, and other features indicating intense geological activity in the past. We contemplate the mysteries of Uranus, a planet full of surprises. Next, we reach Neptune, orbiting at about 4.5 billion kilometers from the Sun. Neptune is similar in composition to Uranus, another ice giant with a deep blue color. Its vivid hue is due to the absorption of red light by methane in its atmosphere, along with an unknown component that enhances the color. Neptune has the strongest winds in the solar system, reaching speeds of up to 2,100 kilometers per hour. These winds drive massive storms, such as the Great Dark Spot, a storm similar in nature to Jupiter's Great Red Spot. Though the Great Dark Spot has since disappeared, new storms continue to appear and fade over time. Neptune has at least 14 moons, with Triton being the largest. Triton is unique because it orbits Neptune in a retrograde direction, opposite to the planet's rotation. This suggests that Triton was likely a captured object from the Kuiper Belt. Triton has a thin atmosphere and active geysers that spew nitrogen gas, indicating geological activity. As we venture further, we reach the outermost regions of our solar system. We enter the Kuiper Belt, a vast region beyond Neptune filled with icy bodies and dwarf planets. Here, we find Pluto, once considered the 9th planet. Pluto orbits at an average distance of about 5.9 billion kilometers from the Sun. It has a complex and varied terrain, with mountains made of water ice and plains covered with frozen nitrogen. Pluto's heart-shaped Tombaugh Regio is a vast, bright area, rich in nitrogen and methane ices. Pluto has 5 known moons, with Charon being the largest. Charon is so large relative to Pluto that they are sometimes considered a double dwarf planet system. They are tidally locked, always showing the same face to each other. We ponder the vast distances and the cold, remote worlds that lie on the fringes of our solar system. Beyond the Kuiper Belt lies the scattered disk and the hypothetical Oort cloud, a spherical shell of icy objects that may extend up to a light year from the Sun. These regions are the source of long-period comets that occasionally visit the inner solar system. Our spacecraft turns around, and we begin our journey back towards the warmth of the Sun. As we retrace our path, we reflect on the enormity of space and the diversity of worlds we've encountered. Passing Neptune and Uranus once more, we consider the challenges and wonders that future explorers might face. Approaching Saturn, we take another moment to admire its rings, knowing that they may not last forever. Scientists estimate that the rings are gradually losing material, and in about 100 million years, they may disappear entirely. We pass by Jupiter, and this time we focus on some of its lesser-known moons. Amalthea, with its reddish hue, is irregularly shaped and covered in craters. Himalaya, the largest of Jupiter's outer moons, orbits far from the planet and is part of a group of moons that share similar orbital characteristics. As we enter the asteroid belt again, we visit some notable asteroids. Vesta, one of the largest asteroids, has a differentiated structure with a core, mantle, and crust, much like a planet. It has a massive crater at its south pole, Rhea Silvia, with a central peak over 20 kilometers high. This impact likely ejected material that has reached Earth as meteorites. We also pass by Pallas and Hygeia, large asteroids with unique features. Our spacecraft continues towards Mars, and this time we focus on its 2 moons. Phobos and Deimos are small and irregularly shaped, possibly captured from the asteroid belt. Phobos orbits so close to Mars, only about 6,000 kilometers above the surface, that it completes an orbit in just over 7 hours. As we near Earth, we take a detour to visit some near-Earth objects. These are asteroids and comets with orbits that bring them close to our planet. Studying these objects is important for assessing potential impact risks and understanding the dynamics of our solar system. Our journey brings us back to the Moon. We consider the possibility of future lunar bases and the use of lunar resources for space exploration. The Moon's regolith contains helium-3, a potential fuel for nuclear fusion. We contemplate the lunar far side, which always faces away from Earth, and its potential as a site for radio telescopes shielded from Earth's interference. Finally, We re-enter Earth's atmosphere, feeling the gentle pull of gravity once more. Our spacecraft descends through layers of air that thicken gradually, slowing our speed. We touch down softly back where we began. As we conclude our journey, we reflect on the incredible diversity and beauty of our solar system. From the fiery sun at its center to the icy bodies at its edge, each component plays a role in the grand cosmic dance. The vastness of space reminds us of our place in the universe, a small but significant part of an intricate tapestry. Allow yourself to feel the calm and wonder of the cosmos settling within you. Let the gentle rhythm of the universe lull you into a peaceful sleep. Breathe deeply, knowing that you are part of something vast and magnificent. Good night.